Good morning students, welcome to Konnur online classes. Previous classes we can discuss the concept of permutation and combination. Here permutation means it's the arrangement. Combination means it's a selection. On the basis of that concept, already we know various type of problems. Here basic importance of NPR is equal to n factorial divided by n minus r factorial. Here in this concept, n value greater than or equal to r value. R value should not be greater than n value. That's why suppose 5 members are there, in which 6 members we can choose. It is not possible. That's why here total n values are greater than or equal to r value. N values always greater than or equal to r values. R value equal to n value or less than n values are possibility. Here NPR means here n number of possible outcomes are there, in which 6 numbers we can arrange with here n factorial. NPR is equal to n factorial divided by n minus r factorial. Here always n factorial means n minus 1, n minus 2, so on up to 3, 2, 1. Here this is the expansion for n factorial. For example, 3 factorial. Here 3, 2, 1. In place of n, 3 is there. Here 3, 2, 1. Up to extend 1 barometer extension module. Here this is the basic concept. Already we know that 8 P1 factorial value. Here 8 factorial divided by 8 minus 1, 7 factorial. That is 8 into 7 factorial divided by 7 factorial. 7 factorial get cancelled. We get the 8 value. 10 P2, 5 P3. Here already we know that all the concepts. Here on the basis of that regarding concept, we go to the next various type of permutation. Here it's a very important concept. Various type of permutation. Here in this concept we can choose first type. Various types of permutation. Various types of permutation. Here in this concept, type 1, when certain number of things always occurs together. Here this is the first type. Various type of permutation. Permutation means arrangement. Here types of the permutation. Various type of permutation. Here in this concept we can choose first type is when certain number of things always occurs together. Here on the basis of type 1 we can choose example 1 and example 2. Example 2. Here in how many ways can 7 people be seated in a row for photograph if 2 particular people always wants to be together? Here we can draw a rough diagram. Here this is 1, 2, 3, 4, 5, 6, 7. 7 members are there. In these 7 members, people 1, P2, P3, P4, P5, P6 and P7. This is a one row. This is the first arrangement. Here in this concept, people 1 and member 1 or member 2 or people 1 and people 2 always together. Here in how many ways can 7 people be seated in a row for photograph if 2 particular peoples always wants to be together? Consider people 1 and people 2, these two members are always comes together. Here, how many types of rows are made for the photograph? Here, people 1 and people 2 always seated in a particular one wants to be together. Here, consider this is a type 1 arrangement. Here, this is a type 2 arrangement. Type 2 arrangement. Type 2 arrangement. Here, 1 and 2. In 1 and 2, here this is a one arrangement. Here also one arrangement. 1, 2, 3, 4, 5. Sorry. Here, this is two peoples are always wants to be together. Here this is one type. Here also one type we can mention. Here 1, 2, 3, 4, 5, 6 arrangements are there. Here only these two peoples are always together. Remaining are alternatively changes. That's why totally we can consider 1, 2, 3, 4, 5, 6. Here mentioned as a 6 factorial. 6 factorial. And always here these two peoples are there. Here these two peoples we can arrange in a 2 factorial. 2 factorial ways. Here this is a very confusing one. Always here mentioning in how many ways can 7 people be seated in a row for photograph if two particular peoples always wants to be together. Here consider people 1, people 2, 3, 4, 5, 6, 7. 7 peoples are considered are seated in a one row. Here in this concept, two members are always wants to be together. That's why we can take this is a one type of arrangement. Here this is a one type of arrangement. Total arrangement is 1, 2, 3, 4, 5 and 6. That's why we can mention 6 factorial. 6 factorial arrangement. Finally, there are two members. They are always wants to be together. That's why suppose the 3 people are always wants to be together. Here we can choose. Here this is 1, 2, 3, 4. 4 factorial. 1, 2, 3, 4 plus 5. 5 factorial into 3 factorial. Suppose 4 members wants to together. 1, 2, 3, 4. Here 4 people wants to be together. Then 1, 2, 3 and 4 factorial into 4 factorial. Here this is a very important concept. Here this is one type of problems and remaining you can take here. In how many ways 7 people be seated for photograph if two particular people always wants to be together. That's why we can take here this is one group 1, 2, 3, 4, 5 and 6 factorial into here these two peoples here 2 factorial. Suppose in this place this is our answer. Suppose in this place 3 peoples wants to be always together. Wants to be always together. Here consider this is 3. 1, 2, 3, 4. Then 5. 5 factorial into remaining 1, 2, 3. 3 factorial. 3 factorial. Suppose here 4 peoples are in this place. 4 particular peoples always wants to be together. Here 1, 2, 3 then 4 factorial into 1, 2, 3, 4 factorial. Suppose 5 peoples are wants to be together. Here this is extended to 5. Here 1, 2, 3, 4, 5. 5 because 1, 2, then 3. Here this is the 3 factorial into 1, 2, 3, 4, 5. 5 factorial. I think this is the clear. In the same way goes to example 2. In how many ways can 7 maths books, 8 statistic books and 4 accountancy books can be arranged in a cell if maths books are always together? Here, in how many ways can 7 maths books, 8 statistic books, 4 accountancy books can be arranged in a cell if the maths books are always wants to be together? Here, first we can make this is a one box. Here 7 maths books are there. 7 maths books are there. Here another one box. Here 8 statistics books are there. Statistic books are there, and another one. Here 4 accountancy books are there. Here question is, here if the maths books are always wants to be together, maths books are always wants to be together, consider oneself. Here arrangement, 7 maths books are arranged and 8 statistic books are arranged, 4 accountancy books are arranged. In these particular cases, randomly we can arrange, but question is, first thing, here 7 maths books are arranged always together. That's why here 8 plus 4, 12 arrangement, 12 plus 1, 7 books are arranged always together. That's why 8 plus 4, 12 plus 1, 13 factorial. Here total maths books are 7 books. That's why 7 factorial. 7 factorial. In this place, we can arrange 8 statistic books are always wants to be together. Here 7 plus 4, 11 factorial into 8 factorial. Here 4 accountancy books are always wants to be together. Here 7 plus 8, 15 factorial into 4 factorial. This is our answer.